All right, 1.8, 1.10, day 3. So we're going to be taking all this stuff we've been talking about this week, and we're going to put it all together into our graphing here. So for each rational function, we're going to do the following. We're going to identify any zeros and vertical asymptotes and holes like we've been doing this week. We're going to be determining the end behavior of the graph. If it has a horizontal asymptote, we want to mark that on our graph. We want to express any vertical asymptotes, horizontal asymptotes, and holes using limit notation. I'm not going to actually really stress this one right now. We will be using a sign chart and table to get some other points to know where we are above or below the x-axis. And then we'll just kind of connect our points and sketch a graph. So let's go ahead and do our first one here. And we're just going to find all that information we've been finding, starting with our holes. But first off, we need a factor. Can I factor this? Can I factor 3? What about x minus 2? So that's as factored as we can go. So, are there any holes? No, no holes. Let's see, next, let's do some vertical asymptotes. Do I have any vertical asymptotes? What do I set equal to 0, top or bottom? For vertical asymptotes. Which one? Bottom, bottom. X minus 2 equal to 0. So where is my vertical asymptote? At positive 2. Now, we can put that on our graph. So at positive 2, we are going to have a vertical asymptote. So just a nice dotted line at positive 2. So wherever you have a vertical asymptote, we're going to mark it with a vertical dotted line. All right, let's go ahead and find our next thing. Hole, or not, we already talked about holes. Zeros, let's do zeros next. Any zeros? What do we set equal to 0 for the zeros? Top or bottom? Top. Can I set the top equal to 0? No, that's not true. So do we have any zeros? No, there are none. No zeros. Let's see. Let's do our, we've done zeros, vertical asymptotes, holes. Let's go ahead and do 2, the end behavior. So our horizontal asymptote, we want to see if we have one. So horizontal asymptote, end behavior. Remember, we set the leading term in the top divided by the leading term in the bottom. What's our leading term in the top? What's the only term I have in the top? What is my leading term in the denominator? So what does this mean? Do I have a horizontal asymptote? We just talked about this. What is our horizontal asymptote? At 0. Okay? As x gets very, 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 very large, this is going to 0. This becomes a very small number as x gets very large. So our horizontal asymptote is at y equals 0. Let's go ahead and mark that on our graph. So at y equals 0, we have a nice horizontal line. That is our x-axis. Horizontal asymptote. On that one, we can go ahead and express that in limit notation. Let's at least do that one. Let's do our end behavior in limit notation. So this would be the limit as x goes to negative infinity of our function. Where is our function going to as we go to infinity? 0, right? And the limit as x goes to positive infinity would also be going to 0. So when we have that horizontal asymptote, our function is going to be approaching 0. So when we do that on our graph, whether we are on the top or bottom of this line, we're going to be approaching 0 as we go to the negatives. As we go to the positives, we're going to be approaching 0. I'm not going to be, doing all sorts of stuff. I'm going to be coming up and approaching 0. Okay, let's see. We did our horizontal asymptotal limit notation. I'm not going to worry about the other two. Let's go ahead and do a sign chart for knowing above or below. It's what we practiced on our warm-up. So what do we need for this? What do we need? What do we put on our sign chart? The vertical asymptote, or zeros. Do I have any zeros though? No, so what am I putting on? Just the vertical asymptote. Now I need 2 points, one on either side of 2. What would be some good points to plug in? All right, 0 works. What else? All right, 4, that works. So plugging in 0 and 4. Now this one's easy enough, I can just go ahead and plug this in. So if I plug in 0, that would be 3 over 0 minus 2, which would just be negative 3 halves. What is negative 3 halves? It's 3 divided by 2. 1.5, 1.5. So that's our point, 0, negative 1.5. So we are below the x-axis. This time we actually do care about the value because we're going to plot that point. All right? And then I plug in 4. So what is that? 3 over 4 minus 2. What's 4 minus 2? So 3 halves. What did we just say 3 halves is? That is positive, so I'm going to be above the x-axis. So 4, 1.5. We are going to plot those points. So no longer do we just care about positives and negatives. We want to plot those points. So 0, negative 1.5, 0, 1.5, and 4, positive 1.5. Okay, so those are the 2 points we're going to use. Now I'm just going to sketch a graph. All right, as we go to negative infinity, what did we say we're approaching as we go to negative infinity? 0. So from this point, I should be coming up and approaching 0. So from my point, I should be coming up and approaching 0. Now, what do you think I'm going to do after this point? Am I going to suddenly jump up and go to infinity here, or go down to negative infinity? What would make the most sense? Going down, right? Well, one thing, I can cross the horizontal asymptote, but that would mean I would have a 0. Did I have any zeros? No, so I should not be crossing this x-axis. So that means from there, I should be continuing coming alongside my vertical asymptote and approaching negative infinity. So that means, and we can write that in limit notation, the limit as x approaches 2 from the left, our function is going to negative infinity. All right, on the right-hand side, from this point, I'm going to be approaching 0 again. That's what we said. And then what makes the most sense? Going up to positive infinity or jumping and going down to negative infinity? Going up or going down? What makes the most sense here? Going up. I'm not crossing the x-axis. We can plug in more points to make sure that that's what happens, but that is what happens. And also, here's another key indicator. We got a positive in this section. We didn't mark that. Let's mark that. So in this interval, we were negative. In this interval, we were positive. So everything here should be staying below the x-axis. Everything to the right of 2 should be staying above the x-axis. I shouldn't be going down. So, there we go. That is our graph. And again, we can write that limit statement. The limit as x approaches 2 from the right of our function is equal to positive infinity. All right, so there is a sketch. Go ahead and make sure you have that. I want you to start looking at B and start identifying our key features and maybe start putting stuff onto the graph. We'll go over it all together in just a little bit, but go ahead and try B. Start identifying that information. All right, let's go ahead and start looking for our key information for B. Let's start with factoring. Tyler, what would our top factor to? All right, and then the denominator, Tyler, what can we factor out? -2, there we go. That is our factored form. Okay, let's see. Nathan, is there anything that's the same in the top and the bottom? Yep, and so then that will identify our holes for us. So, we have some holes, or at least one hole. And that hole is at when x minus 2 equal to 0. So we have x equals 2. Okay, one thing that we haven't done up to this point when we're finding our holes, all we've done is say there it is, at x equals 2. But when we want to graph, we actually want to know where am I going to put my hole? Where is it located? So I need to know what is that y value. But if I plug in 2 straight into my function, I would get 0 over 0. So how do we find out where the hole is located? Well, what we do is we're going to plug it into what is remaining to find that point. So plug in to what is remaining. To find the point. Okay, so what I mean, what is remaining? Think about if I was to actually cancel out the x minus 2. I would have x plus 1 over x over 2x left over. That is what I'm going to plug it into. So I'm going to take my x plus 1 over 2x, what is remaining, and I'm going to plug in 2. So that's 2 plus 1 over 2 times 2, which gives me 3/4 or 0.75. So now I know my hole is located at the point 2, 0.75. And I can go ahead and put that on my graph. So at 2, 0.75, about right there, I'm going to have a hole. So above a half, below 1. Halfway between a half and 1. 3/4. So if you have a hole, you do want to find where it's located, and you do that by plugging it in to whatever's remaining after canceling out the hole. Okay, let's go ahead and find let's do our vertical asymptotes. Dean, what would I set equal to 0 to find my vertical asymptote? The denominator, what's left in the denominator to set equal to 0? The 2x. I don't include the x minus 1. 2x equal to 0. So my vertical asymptote should be at x equal to 0, just like the last one. Let's put a nice vertical line down at x equals 0. All right, let's go ahead and find any zeros. Ava, how would I go about finding my zeros? So what is left that I can set equal to 0 in the numerator? Just x plus 1. I don't want to include the x minus 2 because it's part of the whole. So I have an x-intercept at x equals -1. Now that is a point. It is a 0. negative 1, comma 0. So at negative 1, comma 0, I have a point. Okay, next we're going to find our horizontal asymptote or end behavior. So as a reminder, this is what we take the leading term in the top, leading term in the bottom. Zach, what would be our leading terms? Numerator first. And then we're going to divide that by 2x squared. And what happens there, Zach? 1 over 2. So ladies and gentlemen, do we have a horizontal asymptote? At a half. Horizontal asymptote at y equals 1/2. Okay, so that would be right here at a half. So that's actually going to go between those 2 points, a little bit underneath my hole and a little bit above my 0. That's my horizontal asymptote. Okay, we need to get some more points. That will be using our critical points. So we are going to use, let's see what I have not used yet. I have not used, let's do orange, why not? All right, so to find where we are above and below, getting some more points for my graph, we are going to use the our vertical asymptote was at x equals 0, and our 0 was at x equals negative 1. So we set up a sign chart. So 0, negative 1. All right, so Nick, what would be a good point to pick? Maybe one left of negative 1. What would be a good value? Okay, negative 2. So I'm going to plug in negative 2. All right, let's see. Ellie, what would be another good point to pick? Positive 1. All right, that's in this interval over here. So I'm going to plug in 1. I need one more point between negative 1 and 0. What would be a good point there, guys? Negative half, yeah. So negative 0.5 would be a good one to plug in. All right, this is what we picked last period, so I have our values here. If we plug in negative 2, we get positive 1/4. Plug in negative 0.5, I get negative 1/2, so actually the same thing. And then plugging in 1, I get positive 1. So that's interesting. So I have my 3 points there that I'm going to plot. Negative 2 and comma 1/4. Negative 0.5, comma negative 0.5. And 1, comma 1. So to the right of negative 1, I'm going to be above the x-axis. Between negative 1 and 0, I'm going to be below the x-axis. And then right of 0 is going to be above the x-axis again. Positive, negative, positive. Let's go ahead and plot those points and see what we have. So negative 2 and 1/4 put me about right here. Still below my horizontal asymptote. Negative 1/2, 1/2. Negative 1/2 would put me in the middle of this square. Right there, and hopefully we can kind of see that curve forming there. And then 1, comma 1 would put me right here. So hopefully it's not too far gone to see that our graph would end up going alongside our horizontal asymptote, going towards negative infinity, and then as I go to 0, I'm going down to negative infinity. As I'm going to 0 from the right, I'm going to be going up to positive infinity. And then as I go to negative or go to positive infinity, we are going to 1/2 alongside. And that is B.